these software to applications in civil engineering. Actually, when we were discussing a few days back, when NEP has announced, National Education Policy has announced software that applications in engineering has not, has remained as when we were discussing the applications a few days back. Other areas should also be involved in the national education policy has maximize our application. Engineering has not. Therefore, since for many years we are talking as we were discussing the applications moving across the other areas. Now the engineering has announced has been changing maximize it is not restricted to mechanical engineering. Has restricted to civil engineering. For many years we are talking as and we have to reach other applications moving across the other areas. Very best example who has crossed all the boundaries and reached many domains is Dr. Revdiger, because we have seen his commitment in the earlier days. He committed so much that he went to Roorkee with a GATE score and he did his masters, and immediately he committed to go to US, wherein he can pursue his PhD program, and he achieved his goal and pursued PhD and continued his job in US, and he did a lot of things there. So whatever the software applications to civil engineering you name, in all the areas he has worked very hard. So he is a great example that if one is committed and if one put hard effort, so definitely the strong commitment and hard work will result in achieving the goal. So therefore, I requested Dr. Revdiger to be part of this today's event so that we can see his effort and see his reach, how he has reached different domains. So our faculty and entire all the participants will come to know what are the areas of software applications we can utilize to our civil engineering domain. So different resource persons have agreed to share their valuable knowledge in this program. I should thank the Department of Civil Engineering also for organizing this event, especially the coordinator Snehata Madam, Prasanna Nadagoda, and the HOD to organize such an event and reach all the resource person. Today's resource person is Dr. Ugi sir, and he has developed inverse modeling during his PhD. It's a tremendous work he has done. We were with him when he was doing PhD. We were knowing how he was hardly working on this inverse modeling and genetic algorithm. We usually talk about experimental investigation in civil engineering because Dr. Revdiger had also completed his PG in Roorkee. He knows how tremendous work has been done in experimental investigation in Roorkee, especially earthquake engineering. So this experimental work in civil engineering is very hard to do, and experimental data which we obtain has to be correct, and we should model them. And if we use a technique where you can model this data, especially this inverse modeling, as you are going to receive the information after this session, with a minimum experimental work data or the work which has been carried in the past, we can model the things. So such applications are there, especially today's keynote speaker has focused on artificial intelligence and machine learning and big data. So these are coming in a big way. So we should utilize, as a civil engineer, we should not say that these applications are not for us. Definitely, one of the resource person who is going to deal on AI and ML from Indian Institute of Science, Bangalore. So definitely they throw more light on these AI and ML. So we should go on utilizing these applications for maximizing our reach and optimizing our structures. So therefore, today's speaker and these 5-day sessions are going to help all the participants, and in future they also work, if they are doing if they are a research scholar, they can work on these areas, or they can discuss with their students and create interest in such areas, so that civil engineers will not stick on to civil engineering domain. They can move across and they can select open electives from other domains, and They can also be, after 4 years of graduation, they may be, have a skill and knowledge so that they can easily, acquire a job even beyond this civil engineering as well. So therefore, I think these 5 days programs is very, very important from all faculty point of view, so that across the boundaries we can learn many things. Fuzzy logic is there, which will be dealt by Dr. Todugoder from IIT Madras, and AI and ML I from Indian Institute of Science. A resource person is available, and one person from BBW is throwing more light on vibrations and applications of MATLAB. So things are coming in line, and therefore I request all the participants to take maximum advantage of this by attending this 5 days program. And I hope this will create interest in all the faculty to apply their these techniques in our civil engineering. I think from my side I am done. Thank you very much, Dr. Revdigar. Thank you very much, Dr. Hugi sir, and others. And Shiratti sir is also there, who is also from Bijapur. Mahesh Shiratti is my friend, and he is going to deal on GIS and remote sensing. So we all are there with the participants. Definitely, these 5 days will help them. Thank you very much, madam, and over to you.
Thank you, sir. Thank you for your valuable words. Now, let us move on with the end of the session, this inaugural session. I thank our beloved principal, sir, for giving this opportunity to organize a 5 days FDP program. And I thank special thanks to our keynote speaker, Dr. S.P. Revdigar, sir, for their valuable time with us, spending some time with us and sharing their vast knowledge about the AI and machine learning techniques. I also thank our beloved HOD, sir, Dr. B.S. Patil, sir, to be the part of this inaugural function. And I also thank all the participants and as well as my dear colleagues being the part of this wonderful inaugural function. Thank you very much. Now we shall begin with the first session by Dr. V.P. Huggi sir on a topic inverse modeling in water resource engineering and techniques used in using the genetic algorithm. So I request all the participants to rejoin the meeting at 11:10 a.m. The resource person will be heading over with the session at 11:10 a.m. So I thank all the participants as well as the other gathered people. Thank you one and all. Dear participants, will come back at 11:10 a.m. We can join the meeting within 5 minutes of the session also. We'll begin with the first session.
Sir, your voice is not coming. Hello, sir. Your
Yes,
voice
sir.
is not.
Sir, we will be joining again at 11:10 a.m. for the next session, sir. The inaugural function is over and we'll be joining again at 11:10 a.m. for the first session. share screen ಮಾಡ್ತೀನಿ.
Ma'am, voice is not coming. Hello, Sneha ma'am.
Yes, sir. Yes, sir. Sir, we are
आपकी
the
आवाज
inaugural function is over now. We'll rejoin the session at 11:10 a.m. The session will start at 11:10 a.m. Sir.
okay ma'am. Okay, thank you ma'am.
Okay. Yes, sir.
Really? Ma'am, can I leave?
You can leave and we can rejoin at 11 o'clock, sir. Yes.
ಸ್ಲೈಡ್ ಔಟ್ ನಂಗೆ ಸ್ವಲ್ಪ ಹೇಳಿ ಹೋಗ್ಬಿಡ್ರಿ.
ಹ್ಞೂ ಸರ್. ಏನಿಲ್ಲ ಸರ್, ಇದು ಶೇರ್ ಐತ್ರಿ. ಶೇರ್ ಹೊಡೋದ್ ಬಿಟ್ರ ಆತ್ರಿ, ನಿಮ್ದು ಸ್ಕ್ರೀನ್ ಬರ್ತೈತ್ರಿ. ನೀವು ಸ್ಕ್ರೀನ್ ಮಾತಾಡ್ಕೊತ ಹೋಗುದು ಅಷ್ಟೇ. ನಿಮ್ದು ಪ್ರಾಬ್ಲಮ್ ಮುಗಿತನ ಅದ ಹೋಗ್ತೈತ್ರಿ. ಏನ್ ಹೇಳೋದು ನೀವು ಇದ್ರಾಗ ರಿಪ್ಲೈ ಮಾಡ್ಬೋದು. ಯಾವಾಗ ಬೆಂಗಳೂರಾಗ ತೊಗೊಂಡಿರಿ ಸರ್, ಈಗ ಯೂಸ್ ಆದ್ರಿ? ಯಾವಾಗ ಎಷ್ಟು ಹೊಡೆದಾಗ ತೊಗೊಂಡಿದ್ದಾರ? ಅವಾಗ ಎಷ್ಟು ಹೊಡೆದಾಗ ತೊಗೊಂಡಿದ್ದಾರ? ಮನ್ಯಾಗ ಸಿಸ್ಟಮ್ ಇತ್ತಲ್ರಿ, ಮನ್ಯಾಗ ಕಂಪ್ನ್ಯಾಗ ಫೋನ್ ಬಂದು ಮಾತಾಡಕತ್ತೆ
ಅದೇ
ಅವೆಲ್ಲ ಈಗ ಯೂಸ್ ಆಗತ್ತವ.
ಈಗ ಮತ್ತೆ ಆನ್ಲೈನ್ ಮಾಡೋದು ಪಾರ್ಟಿಸಿಪೆಂಟ್ಗೆಲ್ಲ 11 10 ಅನೌನ್ಸ್ ಮಾಡ್ಬಿಟ್ರೆ ನಾನೇ ಮಾಡಂತ ಹೇಳಿದೆ ಅವ್ರಿಗೆ. ಯಾಕಂದ್ರೆ ನಮ್ಮ ಪಿಪಿಟಿ ಲೋಡ್ ಆಗ್ಲಿಕ್ಕೆ.
ನಿಮ್ದು ಇದೊಂದು ವಿಂಡೋ 8 ಹಾಕಿಸ್ರಿ ನಮ್ಮ ಕಡೆ.
ವಿಂಡೋ 8 ಹಾಕಿಸ್ತೀನಿ.
ವಿಂಡೋ 8 ಹಾಕಿಸ್ರಿ. 8 ಮಾಡೋಣ, ಇಲ್ಲ ವಿಂಡೋ 10 ಹಾಕಿದ್ರೆ ಅಂತ ಭಾಳ ಚಲೋ. ಪ್ರಾಬ್ಲಮ್
ಇಲ್ಲ, ವಿಂಡೋ 10 ಹಾಕತ್ತೆ ಹೇಳ್ಬಿಡೋನು. ಮತ್ತೆ ಫಾರ್ಮ್ಯಾಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ ನಾನು.
ಫಾರ್ಮ್ಯಾಟ್ ಮಾಡೋದು
ಮತ್ತೆ ನಮ್ಮ ಇದು ಸಿ ಡ್ರೈವ್ ಅಷ್ಟೇ ಫಾರ್ಮ್ಯಾಟ್ ಮಾಡ್ತೇನೆ ನಾವು. ನಮ್ಮ ಫೈಲ್ ಏನು ಡ್ಯಾಮೇಜ್ ಆಗೋದಿಲ್ಲ. ಯಾಕಂದ್ರೆ ನಾವು ಭಾಳ ಫೈಲ್ ಅದಾವ.
ಅವು ಬೇರೆ ಕಡೆ ಇಟ್ಕೊಂಡು ಡ್ರೈವ್ ಬಿಟ್ಟು ಸಿ ಡ್ರೈವ್ ಬಿಟ್ಟು ಫಾರ್ಮ್ಯಾಟ್ ಮಾಡಿ
ಸಿ ಡ್ರೈವ್ ಬಿಟ್ಟು ಬೇರೆ ಕಡೆ
ಅದು ಓಎಸ್ ಒರಿಜಿನಲ್ ಕೊಟ್ಟಾರ.
ಓಎಸ್ ಓದಿಲ್ಲ, ಕಂಪ್ಯೂಟರ್ ಜೋಡಿನೇ ಬಂತು.
ಒರಿಜಿನಲ್ ಇಟ್ಟರೆ ತಾನೇ ಅಪ್ಡೇಟ್ ಆಗ್ತೈತ್ರಿ ಟನ್ನಿಗೆ.
ಅವಾಗ ಬರ್ತಿದ್ರು ಅಲ್ರಿ ಓರಿಜಿನಲ್, ಆಮೇಲೆ ಹಾಕ್ತಿದ್ರೆ ಕಾಣಿಸ್ತದೆ.
ಭಾಳ ಹಳಿ ವರ್ಷ
ಇದು ಅವಾಗ ಇದು ವಿಡಿಯೋ ಗ್ರಾಂಟ್ ಅಂತ ತಗೊಂಡಿದ್ದು ನಾ. ಇದು ಯಾವಾಗಂದ್ರೆ 2009 ಗ್ರಾಂಟ್ ಬಂದಿತ್ತದು. ಮೋಸ್ಟ್ಲಿ 2010 ಅಥವಾ 11 ಗ್ರಾಂಟ್ ಕೊಡೋರು. ನಿಯರ್ಲಿ 10 years ಆಯ್ತು ನೋಡ್ ಮಷೀನ್. ಅವಾಗ 50,000 ಕೊಟ್ಟಿದ್ವಿ ನಾವು ಇದಕ್ಕೆ.
ಕಡಿಮೆ ಸರ್, ಪೂರಾ ಫಾರ್ಮ್ಯಾಟ್ ಹೊಡಿಬೇಕು ನೀವು. ಪೂರಾ ಫಾರ್ಮ್ಯಾಟ್ ಹೊಡಿಬೇಕು.
ಸಿ ಡ್ರೈವ್
ಇಲ್ರಿ, ಪೂರಾ ಸಿಸ್ಟಮ್ ಫಾರ್ಮ್ಯಾಟ್ ಹೊಡಿಬೇಕು.
ಫೈಲ್ ಹೋಗ್ತಾವಲ್ಲ,
ಕಾಪಿ ಮಾಡ್ಕೋಬೇಕು ಸರ್. ಎಲ್ರಿ ಎಲ್ಲಾ ಕೂಡಿ 24 GB ಮಾಡ್ಯಾರ್ರಿ ಸಿ ಡ್ರೈವ್. ಈಗ ನಮ್ ವಿಂಡೋ 10 ಹಾಕಿ 24 GB ಎಸ್ಕೊತಾರ. ಹಲೋ ಮೇಡಮ್. ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರ. ಆಡಿಯೋ ಬಂದ್ ಮಾಡೀನ್ರಿ, ಈಗ ಕೆಲ್ಸಂಗಿಲ್ಲಲ್ರಿ ಈಗ ಹಿಂಗ್ರೆ.
This is his area, and he is an alpha dog. And while you think that your dog might be sniffing at other dogs' poo, they
ಯಾವ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊತಾರ ಸರ್. ಇನ್ನ 9 ನಿಮಿಷ ಐತ್ರಿ. ಹಿಂಗ ಕೆಟ್ಟಿರ್ತೇನ್ರಿ.
ಇದು ಎದರೇ ಮಾಡಾಕತ್ತಾರ ಅವರು?
ಒಂದ್ ಸರ್ ಸರ ರೈತರಿಗೆ ಅವ್ರ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಕೊಟ್ಕೊಳ್ಳಿ ಚಾಲು ಮಾಡ್ಬಿಡ್ರಿ.
ನಮ್ಮ ಫೇಶಿಯಲ್ ಬರ್ತದೆ,
ಅವ್ರಿಗೆ ಬರ್ತಾರೆ, ನಿಮ್ಗೆ ಕಾಣಂಗಿಲ್ಲ.
ಕಳ್ಸಂಗ ಅವ್ರಿಗೆ ಕಾಣಿಸ್ತಿರ್ತದೆ. PPT
ಇದೈತಲ್ರಿ,
ಅದು ಕಾಣಿಸ್ತದ ಅವ್ರಿಗೆ?
ಕಾಣಿಸ್ತಿರ್ತದೆ. ಬರೇ ಇದು
PPT ಓಡಿಸೋದು ಹೋಗೋದಕ್ಕೆ
ಓಡಿಸ್ಕೊತ ತಗೋತ್ಕೊಂಡು
ಅವ್ರೇನ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಇದ್ರ
ಸ್ಪೀಕರ್ ಬಂದ್ರಿ ಫೋನ್ ಹಚ್ಚಿ
ಮಾಡಲಿಂಗ್ ಅಂಡ್
ಹುಕ್ಕಿ ಸರ್ದು PPT ಚಾಲು ಮಾಡೀನ್ರಿ. ಅವರು ಮಾತಾಡ್ತಾರ್ರಿ, ಒಂದ್ ಸ್ವಲ್ಪ ನೋಡ್ರಿ ಬರ್ತೈತೆ ಅಟ್ಟೆ ಹೇಳ್ರಿ ನನಗೆ ಮಾತಾಡ್ರಿ.
Hello, Professor Oti, how are you?
Sir, audible ಐತ್ sir. Oti sir mostly meeting leave ಮಾಡಾರಿ. Sir is busy with some other session, sir.
Able to see my PPT presentation? PPT?
Yes, sir. Yes, sir. We are absolutely able to see the presentation, sir. You can.
Then I'll exactly at 11:10.
Yes, sir. Yes, sir. I will start the session, sir. I will just introduce you and we'll start it, sir.
Okay.
Okay. Thanks. Start ಮಾಡ್ತೀನಿ.
ಮೈಕ್ ಯಾರಿಗೆ ಗೊತ್ತ ಹೇಳಿದ್ರು
ಬರ್ತದೆ. ಆಮೇಲೆ ಇದು ಜಸ್ಟ್ ನಾವು ಎಂಟ್ರಿ ಹೊತ್ಕೋತ ಹೋದ್ರೆ
ನೆಕ್ಸ್ಟ್ ನೋಡಿ ಸರ್, ಅಲ್ಲಿ ಯಾರು
ಯಾವ್ದು ಇದಾ?
ಅವ್ರು ಇನ್ಫಾರ್ಮ್ ಮಾತಾಡ್ತಾರೆ ಮಾತ್ರ
ಇದರಿಂದ
ಮಾಡ್ಬೋದು.
Welcome back, dear participants. We shall begin with the next session, first session by Dr. VP Hugge sir. Let me introduce the today's resource person, Dr. VP Hugge sir. Sir is a very eminent personality in the area of water resource engineering, and he is having the 36 years of vast experience as an academician and is presently working as a professor in the Department of Civil Engineering, BLD College of Engineering and Technology, Bijapur. Sir is an alumni of NITK Surathkal and has pursued their postdoctoral from IIT Bombay. Sir has served as a principal in BLD College of Engineering and Technology from 2010 to 2019. He's been a part of several irrigation projects of Government of Karnataka. To mention, he's the pioneer and has designed tank filling project, which leads to irrigating thousands of acres of land. He has also served as council member for Vishwesvaraya Technological University, Belagavi. To add on, he has also served as a director for Karnataka Neeravari Nigama Limited and Vishwesvaraya Neeravari Nigama Limited. Sir has published number of research articles and papers in various national and international conferences. He also holds the honor of being a session chair at international conference held in Singapore. With this brief introduction, I present before you our today's speaker, Dr. V.P. Huggie sir, who will be sharing their knowledge with us on inverse modeling by genetic algorithm and parameter analysis. Thank you. I request Dr. V.P. Huggie sir to start the session. Over to you, sir.
Thank you, madam. Thank you. Good morning to all the participants. First of all, I extend my sincere thanks to the organizers, my friend Principal Dr. M.M. Auti and Dr. V.S. Patil and all faculty members who have asked me or invited me to participate in this FDP program as a resource person. So really I am thankful to all the faculty of Gadag Engineering College, especially the Principal Dr. M.M. Auti. Today's my topic is inverse modeling and its applications to civil engineering, and specifically I am going to present today the inverse modeling applications in the groundwater system to estimate the parameters. As we know, in almost all the engineering types of variables, that is the state variables as well as the coefficients or the constants embedded in the governing equations. The constants which have been embedded in the governing equations, normally in the engineering term we used to call the parameters, and the state variables. So in the system simulation, we are getting the information about the system variables, that is the governing variables of the system, provided we know the system parameters which have been embedded or the constants embedded in the, or you can call coefficients or you can call parameters embedded in the governing equations. So if we know the system parameters, then we can get the information about the system variables or the state variables. So that is in the any system simulation, we need the forward problem and also we need inverse problem. So in the forward simulation problem, we are getting the information about the system variables, provided we know the parameters. And we have also inverse modeling. So there, where we can estimate the system parameters by making the inverse modeling. So inverse modeling is nothing but calculating the system parameters. Why this estimation of system parameters is required? So normally we know if we have the system parameters, then only it is possible to simulate the system or to design the system. So to get the parameters, we need a lot of experimentation to get the coefficient values or the parameter values. So to avoid the experimentation, and also it is the time consuming and it is also a financial burden. With the minimum number of parameters or the laboratory values or the experimental values or the observed values, we can simulate the system. We can simulate the system. So now today I am discussing about the inverse modeling. As in the inaugural session, Professor told that the artificial intelligence and machine learning, it is nothing but the inverse modeling. So where we are calculating or we are simulating the system by estimating the parameters. So this inverse modeling I am applied for the groundwater system. So as we know, groundwater is a very important resource of the planet. It has several inherent advantages over the surface water resources. So in view of the increase in population and unabated pollution worldwide, there is an urgent need to manage this vital shrinking groundwater resources efficiently. Then groundwater process being insidious and complex in nature, modeling plays a pivotal role in the design and management of groundwater systems. Prior knowledge of aquifer parameters is also required. Groundwater flow models are used to calculate the rate of direction of movement of groundwater through aquifer and confining units in the subsurface. So as you know, the transport models estimate the spread of pollution concentration in groundwater regime. So the mathematical model techniques have been extensively used in the study of groundwater resources management for the past 20 years. To build a model for the real groundwater system, we need two problems, that is the forward simulation model and its inverse, that is the calibration model or the prediction model, or both are to be solved simultaneously. The simulation problem, that is the forward problem, predicts the unknown states of the system by solving appropriate governing equations, while the inverse problem, it solves or determines the unknown physical parameters or the coefficients and other conditions of the system. So the main objective of this system here, I have developed the coupled flow and mass transport parameter identification model. So here the flow parameters are the hydraulic conductivity, transmissivity, storage coefficient, and the solute transport parameters are the longitudinal dispersivity and horizontal dispersivity. So these are the parameters what we have estimated. So here the main objective is to estimate the flow parameters and mass transport parameters simultaneously. So we need here to need two simulation problems. One is the flow simulation problem and the solute transport simulation model. And to estimate these parameters simultaneously, we have to couple these two simulation models. The next step is the study and analysis of the coupled inverse modeling solutions for various conditions. Then the formulation of the inverse model. So the inverse model is nothing but estimating the parameters. So first of all, we have to develop the coupled flow and transport simulation model, and that has to be coupled with a optimization methods. So there are so many optimization techniques. As we know, we have conventional optimization techniques and non-conventional optimization techniques. So in the conventional optimization techniques, the objective function needs the derivative of the objective function, which is where we are inducing the errors. So, but in case of the conventional optimization technique, definitely we are going to end up with the global optimization optimal point. But whereas in the unconventional optimization techniques like genetic algorithm, simulated handling, artificial neural network, there are so many unconventional optimization techniques. These are all the iterative methods. The main advantage of these unconventional optimization techniques, these techniques won't need the derivative of the objective function. So that is the advantage. These are the search-based techniques or the probabilistic methods. So here I have used both optimization techniques. That is, one is the genetic algorithm and another one is the simulated handling. Both are the unconventional optimization techniques, both are the search techniques. And here also I also used one conventional method, that is the Gauss-Newton Markov algorithm. Then we compared the results of GNM, simulated handling, and GA. We found the results of SA, that is the simulated handling, far superior than the genetic algorithm and the GNM. However, essay, it needs lot of mathematics. So hence its application is very limited in the civil engineering side. But genetic algorithm can be used for all type of civil engineering problems. So here I tried to use the genetic algorithm for the groundwater inverse modeling or the groundwater parameter estimation. Then also the estimated parameters are to reliability of the estimated parameters are analyzed by using the statistics. Then the identification of optimum parameter structure. Then the developed coupled flow and mass transport is applied to the field problem. So the inverse modeling procedure. So how the inverse modeling procedure starts. So you can start or you can begin with the certain input parameters or input values, parameterization, then the input observation data. So in the groundwater, the input observation data here, our head variations in the aquifer, then the concentration variations in the aquifer, then the initial guess of the model parameter. So initially we can guess the constant which have been embedded in the governing equation. There have to be guess or assume. Then the objective function here is calculate the head and concentration distribution using flow and mass transport simulation model. That is the FEM model. Then the system is simulated. So to simulate the system or to calculate the head and concentration, we are using the FEM model. That is the FEM model. Then the objective function is head of the square of the sum of the square of the head and concentration residual. And this objective function is minimized. And as the convergence criteria met, so you can say if yes, estimated parameters, their reliability analysis to be done by using the statistics. If no, then the parameters are to be updated and again the values of head and concentration are to be calculated. Like this, iteratively, this model works. So here, this is a groundwater system. So here I have considered a synthetic problem, that is all the initial conditions, boundary conditions are known very systematically. So this is a 6 kilometer by 6 kilometer area, and the south side it is having the constant head and concentration boundary, and north, extreme north, it is no flow boundary, and the west side the flux is entering to the system, and the east side the boundary is no flow zone. So this is the no flow zone, north and east. This is the, and this aquifer, that is 6 kilometer by 6 kilometer, it is zonation, means it is divided into 9 zones. That is zone number 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called parameterization. Why we need? Because the ground is the soil or the aquifer, it is a heterogeneous in nature. Means all the state variables and parameters are varying with respect to time and space. So at every point, so it will become very difficult to model. So to make it simple, that is the 3-dimensional problem. So what we did in the zone 1, all the parameter values, that is the transmissivity, storage coefficient, hydraulic conductivity, remains constant with respect to space and time. So okay, otherwise, but in actual practice, the soil is of heterogeneous in nature. But here in this model, we have considered this is a homogeneous since and the parameters are constant with respect to space and time in all the zones. In zone 1, the parameters will be remain same, they are not varying. And zone 2, the parameter values are same, 3. So this technique is called parameterization. This is one of the very important step in the inverse modeling. Then we have considered two wells. One is the pumping well, so, and another one is the pumping well as well as injecting the salt concentration of 1000 ppm. That is, P1 is the recharge well where we are pumping water to the aquifer system, and P2 is the pumping well where we are pumping 500 cubic meter per day water and a concentration of 1000 ppm. So totally there are 18 observation wells in the system, and this system is the next is finite element for formulations. So here we have considered triangular elements, and we have used the Galerkin finite element formulation. So the system equations, the governing flow equation, that is Daba by Daba x, Txx, that is the transmissibility. So this is the Txx, that is the variation of T in the direction of x, whose on the plane, whose normal is x, and h is the state variable, that is the head, and variation of this h with respect to x. So this is the two-dimensional problem. And next is the governing solute transport equation. So these equations, the differential equations, have to be solved by using the Galerkin finite element technique. So after solving the governing differential equations by using the Galerkin finite element method, we are obtaining these system equations. So after getting these system equations, then the next is the performance criteria or objective function. So here the objective function is the head of the square of the head of the simulated values and the observed head value. That is the sum of square of simulated head values and also the observed values. So here, since we are estimating both head and concentration distribution in the aquifer simultaneously, so the objective function is the combination of sum of the head values and sum of the concentration, square of the sum of the simulated and observed concentration values. So here, in this, by using this simulation model, now here we have estimated the transmissivity, longitudinal dispersivity, then the transverse dispersivity, that is T, alpha L and alpha T, by using the Gauss-Newton Marquardt algorithm, which is the conventional optimization technique. So here the Gauss-Newton Marquardt algorithm, it needs the derivative of the objective function. So here we need Jacobian matrix. So as we know, when we are taking the derivative of the function, there we are adding the errors. So to avoid this, so we have also used the global optimization technique also. So here the both T, alpha L, alpha T are estimated by steady state condition and also for the transient state conditions. So steady state means the flow and concentration variation in the aquifer system is constant with respect to time. In the transient state, they are varying with respect to time. So these are the estimated values, and these are the graphs showing the iteration number plus for value of the objective function. This is for the transient state. This is for the estimated transmissivity alpha L and alpha T values for the in the various zones. So here in this problem we have 9 zones. So we have estimated here 9 transmissivity values 9 alpha L values, 9 alpha T values simultaneously. So totally we have estimated here 27 parameter values simultaneously. Then for the since this is the synthetic problem, whatever the values, observed values, head and concentration data we use, they are the noise free. Noise free means error free. But in actual practice, in actual field, the data are not the free. They are the corrupt data. The corrupt data is mainly because of the man-made mistake or the instrument error. Because of these reasons, the whatever data we are getting from the field problem, they are of corrupt data or noisy data. So it is required to corrupt the data. So here this is for the synthetic problem. So just we have corrupted the data by using the by generating the random numbers. So that procedure I will explain you. That is the error-free head and noise. That is head and concentration using FM model with normal coefficient distribution is 0, 1. So these are all the. So here also we have analyzed this developed synthetic model for the also we have analyzed the effect of element size. So this is very, very important in the modeling. That is the size of the element. So here in the finite element formulation. So here we have considered the triangular element. So here just for the analysis purpose, first we have described the system with 72 elements, then 160, 288 elements with 169 nodes. In the first problem, it is 49 nodes and 72 elements, and third one is 625 nodes and 1152 elements. So this is just for the academic interest. So we have analyzed, means considering the different types of element sizes, how it affects this. We have studied how this discretization affects on the solution, on the accuracy of the solutions. Then next we have used the genetic algorithm. As we know, the genetic algorithm is an unconventional optimization technique. This method, that is GA, it won't need the derivative of the objective function. It is a search technique, but the only weakness or drawback of this algorithm is there is no guarantee that we are going to get the optimum point. We may end up also local optimum point, but in case of the genetic algorithm, 100% we are getting the global optimum point. But whereas in case of the conventional optimization algorithm, there is no guarantee we are going to reach the global optimum point or the local optimum point. That is the only advantage of genetic algorithm, but it needs lot of iterations. That is the computing time is very high. So to avoid this, so we have also tried to couple both genetic algorithm, that is the hybrid model. We used to call the hybrid model. That is we coupled both genetic algorithm as well as the GNM. So in that, first we have used the genetic algorithm after 200, 300, 400 iterations. When we are going to reach very near to the global optimum point, then we have used those solutions to the GNM, or we are sending those solutions to the GNM and to converge the solution very fast. Only convergency is the problem in case of the genetic algorithm. So in case of genetic algorithm, how it works? So the generation of initial population so of strings. So this is mainly the initial population. It is the 18-bit strings, 16-bit strings. It all depends upon the accuracy of the solution. And coding, so then the selection of coding scheme. So then the running of FEM model for all the sets of variables, that is the strings. Then evaluation of each string in the population, performing the computation with genetic operations. So the main genetic operations are the selection of the best string, that is the reproduction, crossover the selected strings, then the mutation of the strings, then the termination criteria. These are called genetic algorithm parameters. So how genetic algorithm works? So begin with initial values, that is the initial population generation, then the parameter encoding, then the evaluation of the objective function, selection of fitness strings and formulation of matching full. So we are using the matching full for the mutation, crossover operations to generate new strings, mutation on the child string, replace the child string as new generation, evaluation of the objective function. Then if the termination criteria met, then the estimated parameters. Again, the reliability of those estimated parameters are to be analyzed by using the statistics. So how the genetic algorithm works? It is a very simple and also coding is also very simple. So here we have coded the genetic algorithm and the FEM in the Photon 77. So only we have developed our own model and we have used the Photon 77. So the same problem is considered here, the synthetic problem. So, and the GA is used, and these are the estimated parameters. So here, till we have estimated the parameters independently by using the GNM and GE. Then we have compared the result, both estimated parameters of by using GNM and GE. Then another method we have used is the simulated annealing. This is one of the powerful optimization method since it involves a lot of mathematics. Hence, the peoples are not using this algorithm for the applications are very, very limited for the civil engineering problems. Still, there is a wide scope for the researchers. Still, there is a wide scope applying the simulated annealing for the estimation of system parameters. It may be groundwater or any system wherever it is required to estimate the system parameters. So we can use the simulated annealing. So for the researchers, this is the open area. So they can still there is a lot of scope for the application of simulated annealing in the civil engineering problem. The only problem here is it involves a lot of mathematics, but there is no this one. Coding is very simple. So only when you are going to work with this algorithm, you feel very happy how it was. It will become a very pleasure to work with the simulated annealing. So even it is more or far in our studies, we concluded that the simulated annealing is even far superior than the genetic algorithms. That is in this simulated annealing, just it is a very complicated, or as I told, it involves a lot of mathematics. That's why its application is very limited still in the civil engineering problems. So you can just go through the literature. Very few papers or the research papers you are getting on simulated annealing and application to the civil engineering problems. So here, only thing is in this algorithm, select randomly an initial point parameters like T, SY, storage coefficient, alpha L, alpha T at the point X naught and calculate any one point. So, and calculate the corresponding initial values of the objective function, that is the weighted least square method. Then the objective function value, initial objective function value is E0, which is to be minimized. Start the procedure at initial number t equal to T0, that is the initial random selection of the parameters must be within the upper and lower bound for parameters. So here the bounding of the parameters is also very important. Based on the modeler experience, you can put the constraints on the parameters. That is the lower bound constraint and upper bound constraint. Means suppose t, it must be varies between the range of 0 to 100 or 0 to 200. That is 0 is the lower bound and 100 is the upper bound. So it is needs some experience. Based on that, you can fix the lower bound and upper bound for each parameters. Then the second step is introduce the perturbations by choosing a random point x1 in the neighborhood of initial parameter x0. So for this algorithm, there is one book available. That is the Kirkpatrick. So you can refer that book or you can study that book. There you will get a lot of information about the simulated handling. So then we calculate the objective function at objective function E1 at a new point x1 and calculate the corresponding
Sir,
change.
please tell me the book name once again.
Yes, madam.
Please tell me the book name once again.
Kirkpatrick. K-I-R, Kirkpatrick, P-A-T-R-I-C-K.
Okay, thank you, sir.
This is the metropolis concept, that is Kirkpatrick, that is there in the PPT presentation, Kirkpatrick. That book is available, but in only some of the IITs, Bombay IIT, this book is available. Indian Institute of Science, this book is available. In very limited libraries, you will get this book. So this is the flow chart for the simulated handling, how it works. So based on this method also, we have calculated. Then this is the showing the comparison of results estimated by simulated handling and genetic algorithm. And these results, that is the right hand side results, are also, these are the results, that is the estimated parameter values by using SA, GA and GNM. And here we are comparing the results obtained from all the three methods. One is the conventional method, GA and SA, both unconventional methods. And here we have analyzed the problems for the steady state, that is the independent of time. Then the transient state, that is the variation with respect to space and time. So these are the comparisons and comparison results. So from these graphs, it is very, very clear that the values or the results obtained from SA are far superior than the GA and GNM. So these are the results I am showing. Then in the inverse modeling, the next step is, that is the reliability analysis. So because the parameter values, what we have estimated by using the simulation model, whether those estimated parameters are accurate or not, how much those values, those parameter values are to be acceptable. So that has to be done by using the statistical measures. So here the statistical measures of overall fit, that is the estimate, we have calculated the estimated error variance, EEV, then the correlation coefficient, then the analysis of the reliability of the estimated parameters by using the sensitivity analysis, then the computation of sensitivity coefficients, then the composite scaled sensitivity of estimated parameters, that is the CSS values for the both steady state and transient state. So then variance and covariance matrix, that is the coefficient of variation, confidence intervals, because it is more important. So in this problem, mainly we have considered 90% to 95% as the confidential intervals. So the variation of the parameter values is only 5 to 10% from the accurate values. Then the correlation matrix. So this parameter estimation and for the reliability analysis. So there is a book we have used, Beck and Arnold, that is the reliability analysis of the estimated values or the statistics. So the Beck and Arnold, written by the Beck and Arnold, it is one of the good book for the reliability analysis. So if you want, you can refer that book also for the reliability analysis. Then how the CSS value plays important role in the transmissivity for different head and concentrated data sets. So then as I have told, the entire aquifer system, we have divided into 9 zones. That is called optimum identification of parameter structure. That is the parameter structure. This is also one of the very important step in the modeling. Okay, especially in the groundwater modeling, this parameterization, it plays very important role, mainly because the aquifer media is a heteric, it is a isotropic, we are considered it is a isotropic, otherwise it is a heterogeneous medium. So this whatever models, that is the simulated, that is the forward problem and the inverse problem developed for the synthetic problem, that is the simulation model and the calibration model. So both we have coupled, and this problem this model we have applied for the synthetic problem. So next we have tried to apply this for the feed problem. So here the feed problem, the chosen feed problem is the Mahi right bank canal area in Gujarat. So it includes Anand, Kheda districts of Gujarat. So total 8 districts it involved, and the total area is that is the grass command area is about 3,18,000 hectares, and the net cultivable command area is around 2,80,000 hectares. So 2,80,000 hectares means it is nearly 6 lakh acres of land. So we have used this model for this field problem to estimate the parameters. Once we know the estimates, then estimates means parameter values, then that model can be used for the further, that model can be used for the decision making. How we can make the decisions by using the inverse modeling solutions. That is what is happening in the aquifer system after 5 years or after 10 years, and how the heads are varying in the aquifer, and the concentration variation, that is the solute concentration variation in the aquifer. Based on this information, the managers or the decision makers can take appropriate decision so that the aquifer is to be managed efficiently. So this is the study area that is in Gujarat. There is the Mahi right bank canal area. So it includes nearly 9 districts. There is one barrage, that is the Wanakbori Weir. It is constructed across the river Yamuna near in the Gujarat. So here the Yamuna water is diverted to the canal. This is the main canal system, and there are distributaries. So this is the study area. So mainly this area is getting water from the weir, that is the Wanakbori weir, which is the storage structure. So these are the various talukas which are coming under the Mahi right bank canal command area. So these are the contours. Okay, these are the contours of the area, and this entire area is we have developed the finite element model, that is total number of nodes are 395 and number of triangular elements are 692. So this is a zonation or parameterization. Here the entire study area is divided into 10 zones. That is zone number 1. Here the parameters, that is the hydraulic conductivity, alpha L, longitudinal dispersivity, then the transverse dispersivity values are remains constant with respect to time and space. So in this zone again the values are different. So it all depends upon the formation of the aquifer based on the local conditions or borewell data. So we can assess the parameters, and based on that this entire aquifer system is divided into 10 zones. So this is the parameterization, and these are the finite element nodes and elements. The study area is, as I have told, it is the Mahi right bank canal command area, MRBC aquifer. The modifications of FEM based simulation model to apply. So as I have told, the FEM model is first initially developed for the synthetic problem, that is the flow simulation model, then the concentration simulation model, and these two models are clubbed, then it is going to call as the coupled flow and simulation, so flow and concentration simulation model. It needs some of the changes or modifications when we are applying it to the field problem, mainly as I've told, the element size. So the keeping the element size, it depends upon the two numbers, that is the constant numbers, covariant number, that number plays a very important role, and we have to see that that number must be one within the element. So based on that number, covariant number, we can fix the element size. So element size of the triangular element. So based on that, we have the number of elements and number of nodes. So some modifications it is required when we are applying the FEM model, which have been developed for the synthetic problem to the field problem. Then the input data, what we have considered here is 1999 and 2000, 2000 and 2003 and 2004, both pre-monsoon and post-monsoon data. We are considered first, then the initial and boundary conditions, aquifer parameters, net annual recharge. Net annual recharge we have calculated by using the annual recharge coefficient as suggested by Slovakia. So that paper is available. So you can refer that how to calculate the annual recharge in the aquifer system. That method we have used, and this net annual recharge calculated by using the annual recharge coefficient technique. Then the flow and transport simulation, that is we have estimated the head variation and concentration variation in the study area. Then the output is head and concentration distribution in aquifer domain. So this head and concentration, what we have obtained from the model, is compared with the field data. So if they are very closely associated, both estimated head and concentration values by the model and the observed values from the field, if they are matching each other, then only we can say that the model is working, and the whatever parameter values we have assumed is correct? So just by comparison, you can say that the validity of the developed model, okay, it is working for this study area. So comparison of computed and observed percentage-wise distribution of depth. So that is depth of water table from ground, that is 6 meter is the depth. That is the water table is lying 6 meter below the ground surface. So how much computed area is 28%, whereas the observed area is 30%, only 2% variation is there. So in 2003 and 2004, the computed area is 20%, but the observed is 21%. Means this in the entire 280,000 hectares of area, 21% area, the water table is lying 6 meter below the ground surface. So that is the meaning of this table. Then next, similarly head distribution table. Then comparison computed of percentage wise distribution of concentration, that is total dissolved solids in ppm 0 to 1300 in 99 to 2000. Actually observed in the from the field data it is 35%, but whereas computed from the computed concentration from the model it is 32%. So only 3% variation is there. So this is table is that once. So this is the contours, that is the head contours, that is the computed heads and the observed head values in the study area. So this is the comparison of those heads. And similarly concentrations, this is the variation of concentration observed and calculated. Now this is the simulation model is working fine. Now this simulation model again I prefer. So here we have problem. So again here same the K, alpha L, alpha T values are estimated. That is the hydraulic conductivity, alpha L and alpha T. Total number of zones are 10. By using GNM method also we have calculated. By using SA and GA also we have estimated. So this is the hydraulic conductivity values calculated by GNM, SA and GA. So this is in 10 zones. So here 10 zones means we need to estimate 30 parameter values at a time. That is 10 hydraulic conductivity values in 10 different zones, 10 alpha L values and 10 alpha T values. So that's why in the inverse modeling, most of the time the inverse modeling is a ill-posed problem because of the if the number of parameters are more, then this becomes the ill-posed problem. So to overcome that, you have to limit the estimated parameter values. So that is one of the important, that is the number of unknown variables must be equal to number of equations. So that we have to take care. So this is the comparison of calculated head and estimated head or the observed head. Similarly, concentrations, observed concentration values from field data and estimated values from the model, and we have compared. Both the contours are running or very closely. So only as I have told, the confidence intervals we have considered is 95 to 90%, 5% variation and 10% variation. So these are the comparisons of the calculated values from the model and the observed from the observed field data. So conclusions, this present study, it concludes that the three algorithms what we have used for the coupled inverse modeling, both models, all the three algorithms can be used to estimate flow and solute transport parameters estimation. assessing the reliability of estimated parameters. The coupled process inversion model based on observation and head and concentration data yield better results. Estimated parameter uncertainty greatly reduced. Convergence to a minimal sum of squares values was rapidly achieved when both datasets were employed and given equal statistical importance. The numerical analysis is carried to check the validity, stability of solutions of covered inverse model developed based on GNM, SA and GA, reliability of estimated parameters analyzed using diagnostic statistics, obtained estimated parameters suggest the correctness of the obtained system parameters. Optimum parameter structure, that is the zonation pattern, is identified using zonation method and based on the SS, that is the sum of square of head and concentration residual and trace of variance covariance matrix. This has important application in modeling of large aquifer region where often a precise zonation of the entire region is a very difficult choice. So thank you. Any questions, please? Yes,
Sir, there is one query from the participant end, sir.
yes.
Sir, on what basis zones have been divided into 9 numbers? The query has been asked by one of the participants, sir.
Madam, donation is a very important decision what the modeler has to take. Okay, the donation mainly we are considering the objective function value. So here the objective function is sum of square of head and concentration residual, and also based on the statistical result, that the covariance, variance and covariance with this one. So based on these two, that is based on the objective function value and the CSS value, the donation pattern is to be decided. So for this, you can start initially with different parameter donation patterns with 3 or 4 donation patterns. That is, entire zone you can divide into 5 zones, 8 zones, and 10 zones, and analyze which is giving you better results. That is which gives you the better results, whatever results you are obtained from the model and actual observed data. And if the variation is very, very less or both are closely matching each other, then you can make use of that duration plan. Okay.
Okay, sir.
The next question.
Participants can unmute themselves and they can ask if they have any queries to the resource person.
And one more. Okay.
The platform is open for the participants to ask any queries.
Okay, if there is no any questions or queries, so now the people are started using the neural networks for the inverse modeling. That is the artificial intelligence. What in the today's morning inaugural session, Professor has told Reudiger. Reudiger is of course he was our student and very brilliant student. Both Mr. Rauti, Professor Rauti and Reudiger, both are the classmates. And very brilliant. Reudiger is working with artificial intelligence now, that is based on the neural networks. So a lot of applications are going on using the neural networks, simulated handling, GA. So you can, the researchers, you can make the use of these algorithms and start applying in the civil engineering problems for getting the good solutions for the civil engineering problems. Okay, thank you. Thank you for attending this session. Thank you. And again, I am congratulating the organizers, Professor M. M. Auti, Principal Dr. B.S. Patil, and other faculty members of Gadar Civil Engineering, Gadar Engineering College, Civil Engineering Department. Thank you.
Thank you, sir. Thank you for your valuable time spending with us and sharing your vast knowledge about inverse modeling and genetic algorithm in the water resource engineering area of civil engineering. We acknowledge your presence and we once again thank you from on behalf of Civil Engineering Department, Todagara College of Engineering, Gadar. Thank you, sir. I request all the participants to fill the feedback form, which will be shared to your registered email ID and as well as in the WhatsApp group. Kindly submit your day one feedback. We shall again meet tomorrow at 10 o'clock with the two eminent speakers on the different topics. So here I conclude the meeting. Thank you one and all.
Thank you.
Thank you. Thank you very much. Good session.
Thank you. Thank you, everyone.